My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Climate Change Impact Assessment and Adaptation Strategies for Rainfed Wheat, in Contrasting Climatic Regions of Iran. Iran is a country of diverse climatic conditions including humid northern areas, cold northwestern areas, and dry eastern and southern areas, which are vulnerable to climate warming. Wheat is one of the major crops in the world and the main cereal crop in Iran.
That's great, Higgs. Investigating the impact of climate change on wheat production in Iran is very important. This study had two aims. The first aim was to predict the grain yield of rain-fed wheat in 3 provinces of Iran with contrasting climatic conditions under different climate change scenarios. The second aim was to assess the impacts of different nitrogen fertilizer application rates and planting dates, for compensation of the negative impacts of climate change on the grain yield.
Yes, that is so intriguing, Boson. The study area included 3 provinces of Iran. 5 integrative climate change scenarios were used and evaluated. Nitrogen fertilizer and shifting planting dates were tested for their suitability as adaptive strategies for rain-fed wheat against the changing climate. The Crop Model Agricultural Production System Simulator, or APSIM, was used to evaluate the rain-fed wheat yield of the provinces under different climate change and management scenarios.
The paper concludes that all climate change scenarios decreased the growing season length of rain-fed wheat in all provinces. Further, the growing season length declined more by increasing temperature and reducing precipitation. Plants use various resources, for example sunlight, CO2, water, nutrient, and accumulate dry matter during their growing season. Therefore, environmental factors that can decrease the growing season length of a crop would disturb the utilization of these resources and would finally affect the crop's biomass accumulation and yield.
One of the most important factors that can impact on the growing season length of plants is temperature. In wheat, increased temperatures enhance the crop's respiration rate and accelerate its development.
Wonderful, Higgs. It is concluded that rain-fed wheat production in regions with cold climates can benefit from the climate change, but it can be impaired in temperate regions and especially in vulnerable hot regions.
Wow! That is amazing, Boson. Shifting planting date can be regarded as an efficient yield compensating and environmentally friendly adaptive strategy of rain-fed wheat against the climate change in temperate and hot arid regions.
Finally, not only is not the application of additional nitrogen fertilizer at planting a good adaptive strategy, in order to compensate for rain-fed wheat yield reduction under the climate change, but it can also endanger environmental health and sustainability. As an alternative, shifting planting date can be considered a desirable yield compensating and environmentally friendly adaptive strategy against climate change in temperate and hot arid regions.